Hi Math, I'm Andy. Today we're going to look at scientific notation and more specifically how to multiply these numbers together. So let's say for instance that we have a number like 1.3 times 10 to the fifth. So this is a number written in scientific notation. It really represents 1, 3, and then you move the decimal 5 places to the right. So this number is very big. Now let's make it bigger by multiplying this value by something else. How about 5.1 times 10 to the third? Now if I want to multiply 1.3 times 10 to the fifth times 5.1 times 10 to the third, one thing that I am going to notice is really this is 4 different terms being multiplied together. I have a 1.3, a 10 to the fifth, a 5.1, and a 10 to the third. And really they're all connected through multiplication. Now the associative property of multiplication says that I can multiply things in any order if that's all I have. So what I'm going to do is I'm going to take the numbers 1.3 and 5.1 and I'm going to multiply those together. And I'm going to take the 10 to the fifth and 10 to the third and multiply those together. Because I recognize I have the same base raised to different exponents, I can actually use that multiplication rule where you add the exponents together. So by doing that, 10 to the fifth times 10 to the third, I end up with 10 to the eighth. And now 1.3 times 5.1, well, let's kind of just show you that work. If I want to multiply 1.3 times 5.1, I almost pretend that I don't have decimals, and I line them up, and I multiply 1 times 3, 1 times 1, I bring down the 0, 5 times 3 is 15, carry the 1, 5 plus 1 is 6, 3, 6, 6. And then I go back to my original problem, and I say, oh, I had 2 decimal places to account for, so I move my decimal 2 places to account for the decimal. I end up with 6.63 times 10 to the eighth. Now the last thing I want to do is I just want to check that this is in scientific notation. And so we know that this number here has to be greater than or equal to 1, we'll say the number, and it has to be less than 10. That's kind of the official way to write scientific notation. And because 6.63 is bigger than 1 and less than 10, times 10 to the eighth, it looks like we have our solution to 1.3 times 10 to the fifth times 5.1 times 10 to the third. So again, we just multiplied these in different parts. But let me take you through just one more example where we might see something a little different happen. So let's try multiplying these two numbers. 2.4 times 10 to the third multiplied by the scientific notation 6.3 times 10 to the fourth. So we have two scientific notation numbers. They're being multiplied together. We're going to use that same technique. Let's take those two numbers. So the 2.4 times 6.3, we're going to group those together. And then let's group our powers of 10. 10 to the third times 10 to the fourth. Now you'll notice in each example I'm using different ways to represent multiplication. I have parenthesis group times parenthesis group. I have the x that can be used as multiplication. So I just want you to know that we're just taking these terms and everything is being multiplied anyway. Now 2.4 times 6.3 is actually 15.6. And 10 to the third times 10 to the fourth, well, we add those exponents and we end up with 10 to the seventh. And so I do my scientific notation check again, and I ask, is this number greater than or equal to 1 and less than 10? And we say that it's not. It's 15.6, which is bigger than 10. So I need to rewrite this by taking the decimal point and moving it back one space. So I'm going to take that 15.6 and I'm going to write it as 1.56. But in doing that, I have to adjust the power of 10. Right now, this decimal is going to move 7 places to the right to get my actual value. But because I moved the decimal one more place to the left for this answer, I need to account for that with my power for 10. And so I'm going to say that it has to be one more jump to the right. So I had to add a power of 10 when I moved my decimal to the left. And so we'll just kind of make a note of that. So when you have to move the decimal left to get your answer, what you have to do is add a power of 10. You have to add a power of 10. So it's going to work the other way. If you have to move the decimal over to the right to account for your answer, you're going to take away a power of 10 on that answer. So if you had an answer of 0.13 times 10 to the second power as like an example answer, you would need to move this decimal to the right one to get 1.3. But so you would have to take away one of those powers of 10 because you already moved the decimal. So I guess the rule here is you multiply the numbers together, check to see that it is in scientific notation, multiply the powers of 10 by adding those exponents, and then account for any extra movements necessary.